All right, guys, so good evening once again. We're back for another session. Now, we're still on algebra, and last week we were looking at multiplication and division of algebraic fractions. We looked at two types of simplification method. We look at when we have common factors both in the numerator and denominator, we generally cancel so that we can simplify our fraction in a much simpler fraction. So when we get the result, it will be in its simplest form. We also look at some fractions where we have, instead of just terms in the numerator and the denominator, we have expression in the numerator and the denominator. In those cases where you have expression in the numerator and denominator, before you're able to cancel anything at all, both in the numerator and the denominator, you will first have to factorize where possible in the numerator and the denominator. So whatever you can factorize in the numerator, you do that first, as well as whatever can be factorized in the denominator, you factorize those before any form of cancellation. All right, and be reminded that you cannot cancel part of an expression with another part of an expression. You have to cancel a whole expression with a whole expression. All right, so with that said, we are going to jump this evening into addition of algebraic fractions. And so the general rule still applies, the same rule that you are familiar with when you're doing numeric fractions. Now, if the denominators are the same, so that is the general, going back to the rules. So before I look at these, the general rule for numeric fraction is that when you're adding or subtracting, if the denominator is the same, you simply add the numerators and keep back the same denominator. So your result would keep the same denominator as whatever the fractions are that you're adding, but you're simply going to sum the numerator and put it over that. Now, in the case where we have denominators that are different, now it is more often you will have to find a common denominator by finding the LCM. So once you find the LCM of the denominators, then your new denominator will be the LCM, and that will be your common denominator. Once you have done that, and then now you convert your fraction based on that new denominator. So your numerator will change. In that second, guys. All right, sorry about that, guys. So as I was saying, you would have to convert when with the LCM as your new denominator. Now you have to convert the numerators by multiplying the numerators by whatever you use to divide the LCM. So generally you would use the previous denominators to divide the LCM, and whatever you get from that, you use it to multiply the numerator to get the new numerator that you're going to put over the LCM. All right. Now, so all of those rules will still remain when we're looking at algebraic fraction. Another thing with fractions is if we have mixed fraction and we are adding them, sometimes if you wish, you can convert your what we call mixed fraction or mixed number, that would be a whole number, and the fractional part, can convert those into improper fraction and then simplify. Now, there are cases where we don't have to really do any conversion. We can just simplify the whole number part separate and simplify the fractional part separate, right? So those are two techniques when we are dealing with mixed fractions. Now, if we are dealing with general improper fraction, then you know that in your result, we generally try to reduce the fraction either to a mixed number or a fraction in its simplest form, meaning that you cancel down as far as possible. All right, so with all of that said, guys, we're going to now look at algebraic fractions. So these same rules that we have done when we're doing numeric fraction, we are going to apply them in the algebraic fraction. All right, so generally, we may want to find the LCM if the denominators are not the same. So that's the first thing you want to check. Check to see if your denominators or the fractions that you're adding or subtracting are the same. If not, you'll have to find the LCM. Now, finding LCM for algebraic or algebra, where you have symbols and letters, well, symbols, letters, and numbers, then you may have to pay special attention to what the factors are, right? Now, oftentimes students confuse finding LCM with HCF, which there are two different processes. So I hope you will just bear in mind that you don't get the two confused. So you must have a clear understanding of how to find HCF as opposed to how to find LCM. All right, so finding the LCM is one of the first thing if the denominators are not the same. Now, the second thing, you are to express each fraction with the LCM as a common denominator. So this would have taken you now to the step after you find the LCM. Now you have to convert the fractions that you use to find the LCM so that you can get some new values for the numerators before you add and subtract. All right, now final step, you would, after doing that conversion, you would just simply add or subtract the fraction by adding or subtracting their numerators. All right, and so you will keep the LCM in the result as the denominator. All right, so let's just look at the first example. Now, so this example here, we have numbers in the denominators. So pretty much the denominators or the numbers in the denominators are not the same, hence the denominators are different. So what is it that we have to first do in this case? Ms. Waysong. Are you hearing me, guys? I hope you're there now. Ms. Waysong, are you there?
Yes, sir. Can you repeat? I just stepped out for a bit.
I was just asking now, what is the first step here that we'll have to do when we're adding these fractions?
So first we'd have to find the LCM.
Right, so, and we would have already know how to find the LCM number. So, Ms. Green, can you tell me the LCM for these three numbers?
12, sir.
12. So can somebody remind me what LCM means?
Lowest common multiple, sir.
Okay. Now, it might be trivial that I asked this question, But when you're dealing with LCM, you're thinking of a multiple. Now, anybody remember what a multiple is?
Sir, numbers that smaller numbers can be divided into without a remainder.
Exactly. So any number, the set of numbers can go into without a remainder. So the set of numbers that you're finding this LCM of here will be 2, 3, and 4. So this is a set of numbers. So the lowest number that these numbers in the set can go into without a remainder, that's your LCM. So just a reminder, so that you have it clear in your mind. So after we find the LCM, what do we do now, Miss Green? Miss Green? Are you there, Miss Green? So only two of you know, you have to participate.
Divide in the number.
All right, so what we really want is to write these fractions so that their denominators now become the LCM. Now we can do this one out of two ways now. I'm going to show you different ways. Now, so what we are saying is that our LCM now has to be 12. So we could do it this way if you wish. All right, just showing you different ways that you can approach it. All right. So all of the three numbers must have 12 as their denominator. So if you want to write back each of them and put their denominator to be 12. Now, so it means that these numbers would give you an LCM 12, but we would have to do something to these numbers to get 12. What would you do to the 2 to get 12?
Multiply by 6.
Multiply by how much? Go ahead, go again, Miss Green.
They're going to multiply it by 6.
Multiply it by 6. So it's the same thing, same number that you use to multiply the denominator to get the 12. That's the same number you're going to use to multiply your numerator. So in other words, if we say 2 into 12 goes 6, then we take the 6 and times the numerator. So we will get 6 times A here. And then now we say what to do to 3 to get 12. You would times it by how much?
4.
All right, so this means you would multiply the B by 4. All right. Now next, what we do now to the C? What we multiply the C by?
3.
Multiplying the C by 3. All right. Is it 3? So we say 4 into 12 goes 3 times. So we multiply by 3. So we get 3C over here. Now, once you have done that, we need to simplify this now into a single fraction. So in order to do that, we just, when the denominators are the same, we just simply add their numerators. So we're going to put back all of these numbers over the LCM as the new denominator. So we know that our LCM would be 12. And so we're just going to add the numerator. So if we add 6a, 4b, and then minus 3c, what we get?
Seven.
What we get, miss?
Sir, we can't add unlike terms.
Well, I wouldn't say that we can't add them. It's just that the result won't be able to simplify into a single term. Because what we're really doing, we're adding them, but they're not simplifying into a single term. Instead, it is simplifying into an expression. You follow what I'm saying, Mr. Isam?
Yes, sir.
Right. So this would be a result. So you wouldn't have changed, the terms, but you would simply put plus or minus between them. All right. So that's the approach you can use. Now, if you didn't want to take this approach, you could go from here, one step, and then now you would say, use each of the denominator, divide your LCM times your numerator. So it's a 2 into 12 goes 6 times, so you have 6 times a, and that just gives you 6a. And then now you keep your sign that you have in the numerator. So we have 3 into 12 goes 4, then you use 4 times b. And then we say 4 into 12 goes 3. So now we have minus 3c. All right, so if you follow this approach, you will actually take only one step to the answer. But sometimes it is good when you show all the steps, because once you show all the steps, what you're doing, you're convincing your examiner that you know exactly what you're doing. All right. All right, so any question, can I clear what is on? And move on to the next slide. All right, so I'm going to clear what I have here, guys. All right, so LCM would be 12. So we would get that as our answer. I'm moving along to our next question. Here we have a slight difference in the denominator here now. Because these set of values in the denominator also include an unknown in them. So the unknown here is x. So can anybody tell me how we can go about now to find the LCM for the denominator? Or can anybody tell me what the LCM is?
6x, sir.
And why do you use 6x?
So because you'd need a common factor for the x as well. A common multiple, sorry.
All right, so, right, so basically you find the LCM for the numbers and group it with the letter to give you the overall LCM. So in this case, you would have LCM for 3 and 2 would be 6, and the LCM for x would be just x. So that's our LCM. And if we do like before, we want to find, so we write all of these, and now put the LCM as our new denominator. So we would have 6x as our LCM for all of these. All right, so what did we do to this first x here, denominator, to get the 6x? What did we do to this denominator to get 6x?
Sir, x times 6, sir.
Right, so that means we multiply this by 6 to get 6x. That means numerator must be multiplied by 6. So we'd have what? 6 times 2?
12.
Give you 12. All right, so for this denominator now, the 2x, what do we do to that to get 6x?
Multiply by 3, sir.
Multiply by 3. So we
3.
multiply the numerator by 3. So we have 3 3s, 9. What did we do to this 3x to get 6x?
Multiply by 2.
Multiply by 2. So the numerator 4 must be multiplied by 2. So we have 2 4s, 8. And so now we are now going to write, them now with a common denominator. So all we have to do now is add the fraction by adding their numerators. So the denominator, common denominator would be 6x. And then now we just simply add the numerator. So we'll add what? 12 plus 9 plus 8. And what do we get when we add them, guys?
29, sir.
So our answer will now be 29
Over 6x.
over 6x. All right, good. So everybody is good with that so far. So let me clear that. Can I clear now, guys? All right, I'll take it that everybody's good with this. Good evening again, Mr. Lamar. All right, so our
Good evening,
LCM
sir.
would have been 6x. We find the common denominator times the numerator by what we use to divide. So that's how we get for our answer. All right, pretty straightforward. Now, things to note, the sign in front of a fraction applies to the fraction as a whole. Now, what do I mean by that? Or what does this mean? Now, if you have a fraction A over B, and so you have a sign in front of the fraction, right in front of the bar of the fraction, what that tells you is that the entire fraction is a negative fraction. Now, you may have some situation where you may have the numerator have a negative sign and the denominator have a positive sign. So what you would have to do now is apply the rules in terms of dividing negative and positive. You say dividing a negative by a positive, you always get negative. So the entire fraction now will become negative. And so you put this sign in front of the bar to show that the entire fraction is negative. All right, is that clear to you guys? All right, I'll take it that your silence means that it is clear. All right, the next thing that we want to know is that a negative sign in front of fraction may change the sign in the numerators or the denominators of the fraction. All right, so that might not be so obvious to you, or you might see it as trivial, but there are some questions that we may need to apply what we know about that in terms of the negative sign, because there are times when we may want to change the numerator sign, or times when we want to change the sign of the denominator. So knowing this will be helpful. All right, so here we have fraction of a little bit different nature from the one that we have just looked at. If you notice now, these fractions have expressions in the numerator. And so when we are simplifying these fractions, now we have to treat our numerator as a single entity. And in order to make your numerator, the expression as a single entity, when we're working with them, it's best to keep them in brackets. So once we keep them in brackets, we are kind of singularizing them as an entire value by themselves. All right. All right. So with that in mind, what would be the LCM for this fraction?
Well, sir.
All right, 12. So like before, I am going to take two different approaches here. All right, so one approach, we could just simply write our LCM in the final denominator as the final denominator. And so in that case, in this case, we would have 12 down. Now, as before, we'll have to divide the 12 by these numerator, and whatever we get multiplied, we have to divide the 12 by the denominators of these fractions, and then whatever value you get from each division, you use it on times the numerator of that fraction. So in the first case, we have m over 12. We're going to take the 12 and divide that denominator 12 and divide the LCM. So we say 12 into 12 goes 1. We take the 1 times the numerator. So we'll have 1 times m. We'll just give you back n. All right, now we're going to keep our signs. So we have our plus sign there. Now for the next numerator, we have an expression. And as I was saying before, to treat them in a singular form, like if in terms of you want to have a singular numerator, you'll have to keep them in brackets to make the numerator singular, because when we do that, it prevents us from making certain kind of mistakes. All right, so keep them in brackets when you're multiplying them. So we're going to say now 4 into 12. So we know that 4 into 12 goes 3 times. That means we are to take 3 times the numerator. Now the numerator is 2m plus n. And so we want to keep it in brackets when we are multiplying. So we put the 3 brackets 2m plus n. All right. So once you do that, it makes your life easier, especially when you're working with negative sign. Now we are going to say now 3 into 12 using the denominator of the last fraction. 3 into 12 goes 4 times. Now note that there's a negative sign here, so we need to bring back that negative sign. So we are going to say 3 into 12 4 times. Now we're going to put 4 now times the numerator. But the numerator here is an expression, so we want to keep the expression in brackets. So we have m minus 2n. Now, After we have done that, now we can remove the brackets in the numerators by multiplying out what is inside them by what is outside. So we are applying the distributive law. So if we do that, so we have our denominator, our LCM is 12. So we're going to say now, there's nothing to simplify with the m, so we just put back the m as it is. Now for this bracket, we are multiplying it by 3, so each term in the bracket must be multiplied by 3 and keep the sign what we have in the bracket. So 3 times 2m give you, anybody?
6m, sir.
All right, so we have 6m. And then now 3 times n, remember keep the sign in the bracket. 3 times n?
3n.
3n. All right, next we have negative 4 times m give you what?
Minus 4m, sir.
All right, minus 4m. And then now negative 4 times negative 2n give you what?
Positive 2n.
Positive 2 or positive 8.
Positive 8n, sir.
All right, positive 8n. All right, so we would have 8n here. Now having removed the brackets now, we can go ahead now and simplify by grouping and adding like terms. Now, we should by now know what we mean by like terms. So when we're grouping here, we can group the m's, the terms with the m's together, and the terms with the n's together. And if we do that, what would we get for m?
7m